Our discussion is on error analysis and calculation. So when we talk about error analysis and calculation, it is the process of identifying, quantifying and evaluating uncertainties in measurement and calculation of results from lab and research work to ensure the accuracy and reliability of the obtained values. So after an experiment has been performed or a research work has been done, we find out the error margins or uncertainties found in the work by using the error analysis method. Error analysis simply helps to find out the error margins found in the experiment performed and how they were yield. So we can use the error analysis method to correct out the mistakes done, the uncertainties found in the lab or research work which was done. Now there are three ways of calculating and evaluating error analysis. These ways are: we have 1, precision error or percentage error; then 2, partial differential error; then 3, standard deviation error. So let's go into details each of the ways used in the error analysis. The first one we will talk about is the precision error, which is the percentage error. This is used to determine the error value when the objective of the experiment had a standard value or a real value that can be compared to the experimented value. So let's say your work you are doing or the lab experiment you are performing, and the objective of that lab work has a standard value that you can compare your experimental value to. You can use the precision error to find out the error margins you had in your experimental value. And this equation is giving us experimental value minus real value all over real value times 100%, meaning this error is always calculated in percentage. So after subtracting the real value from the experimental value and dividing by the real value, you multiply by 100 to get your percentage error. So let's consider this scenario where an experiment was performed and the objective of the experiment was to determine the acceleration due to gravity. So the acceleration due to gravity was asked to perform in the experiment. So let's say a simple pendulum which was hung out, so obviously we asked to find the acceleration due to gravity. So in this experiment, we already know the standard value for acceleration due to gravity, which is 9.8 meter per second squared. And from the assumed experiment, the acceleration due to gravity calculated at the end was 9.78 meter per second squared. So now let's look at how we use the precision error to determine the error margin between these two values. So percentage error equation is stated out here: experimental value minus real value all over real value times 100%. So doing our direct substitutions, 9.7 minus 9.8 all over 9.8 times 100%. So our expected value for the error in this work is minus 0.00204%. So this is the error margin between the experimental value and the actual value. But we have to note that the error is always in plus or minus of the value. So either your calculation gave a negative answer or the positive answer, the final error value must be in the plus or minus value. So we are supposed to note that as stated here. So the next thing we'll talk about is partial differential error. And this error is used when there are no standard or real values for the results obtained in the experiment. After your lab work done, your results being found, there were no standard values to compare your results to. You can use the partial differential error to calculate out or evaluate your error margins between the results obtained in the experiment. So the equation or relation is therefore used to calculate for the error. So the equation that you used in the experiment to get your result is the one that will be used to calculate your error. So let's look at the steps by which we will use in this method. So in the first place, let's consider this equation for this method. So T equals 2 pi square root of L over G. So we are using this equation for this method, you can pick out your equation you use in your experiment, then follow the steps as we go by. So firstly, we will simplify the equation. That is, looking at the equation we have here, we are supposed to eliminate the square root to make the equation simple. So by doing that, we square both sides of the equation, getting t squared equals 2 pi square root of L over G all squared. So simplifying out the equation, the square root will be taken out, for we having t squared equals 4 pi squared times L over G. So after that, we take the log value or the log of the equation. After that, we take the log of the equation. So we should be mindful of the laws used in logarithm. So these laws will be applied here. So we should be mindful of the laws used in logarithm. So the equation that we yielded was t squared equals 4 pi squared times L over G. So applying log to every side of the equation, we had log t squared equals log 4 pi squared plus log L minus log G. So log 4 pi squared plus, this plus because the 4 pi squared was multiplying L over G. So taking the log value of those variables will be plus. Then since L was divided by G, taking the log value of that fraction will give you minus. So therefore we have log L minus log G. So breaking the equation down, we had 2 log t plus log L minus log G. Someone may ask why we didn't touch the 4 pi squared. It is a constant. There are no variables in that expression, so there's no need for us to touch that. Now we take the partial differential of the equation we've had here, which is 2 log t equals log 4 pi squared plus log L minus log G. So taking the differential, we're having 2 delta t over t, which equals delta L over L minus delta G over G. So we will not take into consideration 4 pi squared. We will eliminate the 4 pi squared from the partial differential. Now we have to make delta G the subject, since that will give us the error for the gravity. So making delta G the subject, we are supposed to bring delta G over G to the left side of the equation. And after that, we multiply through by G to make delta G the subject. So therefore, our delta G will be equal to, into bracket, delta L over L minus 2 delta T over T times G. So this equation is how to be used to calculate for our error for gravity. Now, delta L and delta T can be found from your table. So you look at your table of values and you look at the values of L and T. Then you look out for least count from the table. So your least count is number of decimals. So let's say you have a value for L which is 2.5. Your least count for that 2.5 value would be 0.1, since your decimal place in that value is 1. So the least count is 0.1. So the number of decimals you have, the number of zeros that will appear. So let's say you have a value for t which is 0.256. So that your least count for that will be 0.001, because the value is 0.256. So the 256, 2 will be 0, 5 will be 0, then the last value, which is 6, will be 1. So the least count, therefore, will be 0.001. So you are supposed to note that as well. If the value on the table is a whole number, the least count is 0.1, because all whole numbers have point zeros. So we are supposed to note that. And the G at the end of the equation here is the experimented value that you had in your results, not the actual value that we know. So we use G here to find the experimental value. That is what you use to put in the equation to get your error. So therefore, this is the equation for the error analysis for this part. Now, the last thing we will talk about is standard deviation error. And this approach is used when there are a lot of tables and values recorded. And these values were used to obtain the final results. So therefore, we are supposed to apply standard deviation error to be able to fish out all the errors that were recorded in all the values on the tables. So the standard deviation error is therefore given by the standard deviation all over square root of n, where that symbol del is the standard deviation and n is the number of values on the table. So this is the approach at which we find the standard deviation error. So the approach for determining standard deviation will be used here. So you pick, let's say, value for t. So column t, which we have the values there. You find the mean for that value. You subtract the mean from all the values on the table. You square the x minus mean. Then you use that to find the standard deviation. After that, you divide by square root of n to get your standard error. These are the approaches at which we calculate the error for our lab and research work. So the first part, we have precision error. The second part, we have partial differential error. And the third part, we have standard deviation error. So per your values taken, your equation in the lab work, and your results obtained will tell the method you will use to calculate for the error analysis in your lab work.